Hello everyone, welcome back to Bytes of CAC. So in this lecture, we are going to learn about the role of bias in artificial neural network. Since you have shown interest in this video, I can safely assume that you already know that bias is a constant value that's added to the product of inputs and weights in the most basic equation of artificial learning, that is z equals to wx plus b. So what does this equation remind you of? Yes, this equation reminds you of the equation of straight line y equals to mx plus c. So what we do here in artificial neural network is, or in artificial learning, whatever you like to call it, we try to find an equation that will fit the training data distribution. Now you might ask me that what if the data distribution is not linear? It is not a straight line, and in most of the cases it is non-linear in nature. So this is where the activation function comes in. So what we do here is we draw a straight line using the basic equation y equals to mx plus c, and then we use one of the activation functions to bend that straight line to a curve or a shape that approximately fits the training data distribution. So everything here starts with a straight line, and in order to draw that straight line, we need an equation. Now, what if we just ignore the bias? Like your equation becomes z equals to wx. So this means that your straight line equation now has a y-intercept which is equals to 0. Now when your y-intercept is equals to 0, that straight line is forced to pass through origin, and this means that the model's ability to fit to the data will be limited. And there's also another factor. Suppose for some of your examples, this x vector is 0. That is, all the features have a value which is numerically equivalent to 0. So in this case, 0 values will be propagated throughout the network. And also, if you're using some of those activation functions like ReLU, it will seriously hinder the network's ability to learn or propagate information in this case, if there is a zero bias. So clearly zero bias is not an option. Now your value of Z hangs on Wx and B. Now let's find out how this, when we vary the bias, how will the output be affected? Suppose we have a high value of bias, that is high value with respect to this factor Wx. In that case, the variation of Z will depend more on B and less on Wx, which implies that the model's output will be less sensitive to variation in the input data. And this would mean poor performance on both training and validation sets. So here activation function will shift significantly and the outputs will either be too high or too low than the target. So what if the bias is too low with respect to Wx? In this case, model's output will depend more on Wx and it will start fitting to the noise in the data, which will ultimately lead to overfitting of the training data. So in a nutshell, high bias means a failure to capture the trends in your data, and a low bias would mean it will fit the noise in the sample distribution. Now, if you go through the definition of bias, in artificial learning, bias is considered as a systematic error that occurs in the model itself due to incorrect assumptions in your training process. Technically speaking, bias is the error between the average model prediction and the ground truth or the target. So as you have seen just now, that high bias makes the model gravitate more towards underfitting while low bias towards overfitting. Now the question is, why do we need this kind of an error? In artificial learning, we just see a part of the distribution. Like the samples are randomly drawn from the distribution, and it also includes the noisy samples. We try to assume the entire distribution from the samples or the training samples rather. So the aim here is not to fit to the training sample exactly, but to figure out the distribution of the actual population. Now, bias helps with this factor. This is like a tuning parameter to adjust how well your algorithm fits to your data. So if you decrease the bias, it will fit more to the training data, and if you increase the bias, it will fit fit less to the training data. And this is exactly why bias is used in artificial learning. So I hope that helped you, and thank you for watching.